Good day to everyone. Let's have a look at an example of operating an electronic equipment using a single-phase AC supply. Here an overvoltage of 6 kV hits the power supply of the server. You won't find any SPD installed in this circuit. Now, this voltage reaches the electrical equipment. When the overvoltage exceeds the withstand voltage of the electrical equipment, the internal insulation is not protecting, and the surge current destroys the equipment. A discharge to the ground will also be generated. But, after this overvoltage, the server is out of service, and a risk of fire is present. The installation of an SPD between all live conductors and the earth limits the overvoltage by proposing a safer path and diverting it directly to the ground. With an SPD, a transient overvoltage of 6 kV spreads through electrical cables. The surge protection device ignites and diverts the surge current to the ground. The residual voltage is limited at 1.5 kV at the terminals of the SPD. The server is on the safe side and protected from the overvoltage. But you will wonder how server is safe with 1.5 kV. Let's find out. This is how transient voltage spikes appear in a single-phase AC line. These will disappear within very short period of time, that is around 1 to 30 microseconds. So, MCBs on an electrical circuit do not respond to these transient voltages. Typically, MCBs are designed to operate at less than 2.5 milliseconds when there are short circuit faults, and between 2 seconds to 2 minutes in case of overloads. In this graph, you will find out that any electronic equipment is in danger of getting damaged, facing a voltage spike of over 1.5 kV. So we are compelled to keep these spikes controlled and ground them instantly. Let's look how a surge current of indirect lightning strike behaves. This is known as 820 microseconds surge current waveform. Here, rapidly rising surge current reaches its maximum value of 100% within first 8 microseconds. Then, it takes total of 20 microseconds to get back to the half of that peak surge current. Also, majority of surge currents due to internal switching, that is due to on and off of heavy loads, will follow the same current waveform. When you consider the voltage rise on this occasion, it's almost the same shape as the current waveform. On our example, the peak voltage is 6 kV. SPD lowered it to the level of 1.5 kV. These devices are typically designed to divert or limit the amount of surge energy that reaches sensitive equipment and systems. This is achieved through a combination of passive and active components, including metal oxide varistors, gas discharge tubes, and transient voltage suppressors. In actuality, the response time of voltage-limiting SPD components are similar, and within the nanosecond range. These components of the SPD will combine together to start clamping this excess voltage over 1.5 kV within a nanosecond. So with the SPD in operation, voltage waveform is drastically changed, and the residual voltage is limited to 1.5 kV at the terminals of the SPD. If you observe the surge current flow through the SPD, the waveform is shown here. Hope you got to know interesting stuff here. Thank you for watching the video. Please join us as a patron on www.patreon.com/Electro Academy. Your help on this matter will be mostly appreciated.